continue on reviewing arithmetic. So real quick, let me mention division and zero. So if you have, say, 20 and you divide that by 0, or you have negative 10, you divide that by 0, in both of those cases, it's undefined. If instead you would have had, 0 divided by 20, or 0 divided by negative 10, then the answer would have been 0. So kind of how this works is the bottom number, the divisor, if it's written as a fraction, it's the bottom number. If your divisor tells you how many you want in a set, and then your numerator, your dividend, tells you how much you have. So if you think about, like, if I take 6 and I divide that by 2, what I'm looking for is, if I have 6 of something, how many sets of 2 can I make out of that? And the answer is I can make 3 sets of that. But if I have nothing, and you say, well, how many sets of 20 can I make? Well, I can make no sets of 20. But what does it mean for me to say I have 20 and I want to make sets of size 0? How many can I make? Well, that doesn't really make sense if you think about it. How do I make a set of size 0? Answer is I can make as many as I want. It's not a clear answer. Another problem with dividing by 0, if I have 6 divided by 2 equals 3, well, the reason why that is because 2 times 3 is 6. So think about if I had negative 10 divided by 0 equals some number, okay, whatever that number is. Well, that should have to imply that negative 10, or here, let me back that up so I follow the same pattern I did before. That would have to mean that 0 times this number, whatever this number is, would have to give me negative 10. But 0 times anything is 0, so that doesn't make sense. So again, this answer doesn't work if your divisor is 0. Now, if you're dividing into 0, then the answer is always 0. And that's something that sometimes people get mixed up between. So it's okay if your top number, your dividend is 0, but if your divisor is 0, then it's undefined. You can't divide by 0. Okay, let's move on. I'm going to continue talking about operations. So let's talk about fractions, everyone's favorite. Now, my recommendation is when you actually do your work that you just use a calculator that can do fractions for you, so just speed up the things. And I'm going to speed this up a little bit. But you should know how to do fractions. So let's say I want to add or subtract fractions, and I'll do both in this problem. Let's say I have 2/3 plus 4 half. Oh, that doesn't make sense. Let's say 5 halves. 5 halves. 5 halves minus 1/6. And I want to add and subtract those. Now, what the bottom tells you is how many pieces a whole is split up in. So, if I have a whole, whatever that is, and I'm going to pretend like these are all the same size. They're not going to be because I'm just drawing them freehand. But imagine these are all the same size. So this says this first one is split into thirds, whereas the second one is split into halves, and this third one is split into 6. So, okay. And I'm trying to compare, 2/3 to 5 halves, so I got some more here, and then taking off 1/6. Okay? And I want all different pieces. I can't compare them. And so what we need to do is have them all the same piece. And the way we do that is we find a common denominator. Preferably find the least common denominator. And it's the smallest number all of these go into. So usually the thing you want to do is start with the biggest one, since they all have to go into it. And then ask yourself, does 2 go into 6? Yes. Does 3 go into 6? Yes. So in this case, the least common denominator would be 6. Make them all match. And if 6 didn't work, then what I would do is say, okay, well, let's double 6. Let's go 12, and then check that. And if that doesn't work, go to 18. So use the biggest one to kind of figure these out. So I want all these to be 6 on the bottom. Well, great. This third one is already a 6, but these other two aren't. So in order to change this bottom to a 6, I'm going to multiply it by a 2. But I can't just multiply the bottom of it by a 2, because 2 6 isn't the same as 2/3. Clearly they're not the same. But if I multiply the top by the same number I'm multiplying the bottom by, and make that a 4 6, then what I see is 2/3 is the same as 1 2 3 4 6. So that does work. And then same idea here. I'm going to multiply the 2 by 3 to make it a 6. So I'm going to multiply the top by 3. So 15 6. And now, once I get these sizes all to match, I get everybody to be in size 6s, right? Everybody's size 6. Then I can start, oh, these are how many pieces I have on top. So I can just start adding and subtracting the top. So 4 and 15 give me 19 over 6. And then 19 minus 1 gives me 18 over 6. So how much do I have? I have 3. 18, is this a fraction or is it a division? The answer is yes. It's whatever's most convenient. So in this case, thinking of it as a division makes it easy to find, oh, I got 3 wholes. If you have 18 sixes, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, you got 3 wholes. All right. Adding and subtracting. So find a common denominator, change to equivalent fractions, and then change to equivalent fractions, equivalent or equal value, right? And then combine numerators. And last thing, reduce, if possible. Okay, so multiplying. Let's say I want to take 3/4 times 16 over 9. So what you can do is you can just multiply top times top, bottom times bottom. A negative times a positive is going to be a negative. And then, I don't know why I'm getting this out. I don't need this. All right. So 48, right, 3 times that, and 36, 4 times 9. And then you can reduce. So you can say, well, they're both even, so let me cut them in half. They're still both even, so let me cut those in half. And then 3 goes into both of those, so 4/3. So that's one way you can do it. Multiply top times top, bottom times bottom. Make sure you check your signs. A lot of times, if you want to put this negative on something, you put it on the top. Think of it as a top number. But that's not the only way I could have done this problem. I could have, instead of reducing at the end, reduced at the beginning. So I could have said, as long as one number is on top and one number is on the bottom, so for example, 3 goes into 3 once, 3 goes into 3 9 times. So one of them's on top, one of them's on bottom. Then it doesn't matter if they're in the same fraction or in different fractions. So if I look at, there's a 4 goes into 4 once, 4 goes into 4 times. Now, if I multiply top times top, so negative times a positive is a negative, 1 times 4 is 4, 1 times 3 is 3. So if you have to do everything by hand, a lot of times it's better to cancel before you multiply than to multiply and then try to break it down. You can see it takes a lot longer. Dividing fractions. We don't do it. Instead, multiply by the reciprocal. What do I mean by that? So let's say we have 24 over 16 divided by 12 over 8. Well, I'm not going to do that problem. Instead, what I'm going to do is I'm going to do 24 over 16 times 8 over 12. I'm going to do the reciprocal, or flip the second part of this problem over. And then I'm going to do a multiplication. So I might say, well, 12 goes into 12 once, 12 goes into 24 twice, 8 goes into 8 once, 8 goes into 16 twice. So I get 2 over 2, which equals 1. Remember, if everybody cancels out, that is not 0, that's 1. When you're canceling this out, you're making ones. All right, so you don't divide fractions, you multiply by the reciprocal. Decimals. So decimals. Add, subtract. Line up the decimals. Right? The key there is combine place value is what you're doing. So if you have 3.1 minus 18.04 plus 0.0081, what you want to do is combine place value. So let's say I want to put these first two together. I'm going to take negative 18.04. You always put the larger magnitude number on top, just like they taught you in elementary school. Put the bigger one on top. For that, they always wanted you to get a positive number. We're not going to get positive. We have more negatives here. It's going to be negative. But how many more? Well, negative 4 and 0, that makes 4. You can't take 1 from 0, so I'll have to borrow 1 from here, make that a 10. Take 1 from there, that'll make it 9. 3 from 7 makes that 4, so negative 14.94. And then I'm going to add 0.0081. And again, notice even though I'm saying add, they're not going to get bigger because this one's negative and that's positive. When I say add, that just means the second one's positive. So I'm going to take 1 from 0. I can't do that. So normally I would borrow 1 from here, but this has nothing. So instead I'm going to think of this as a 40, and I'm going to borrow 1 from 40 and make that 39. And then I'll borrow 1. So 1 from 10 is 9. 8 from 9 is 1. 0 from 3 is 3. 9, 14, negative 14.9319. So adding and subtracting, got to do the place value. Again, I would just use a calculator for this, but just kind of a reminder, reviewing arithmetic. Multiplying decimals. If you have negative 2.1 times 0.35, what you're going to do is you're going to multiply these as if they were just integers. So you're going to take like 35 times 21 and multiply those together. So 35 and 70, 537. And then you're going to come back up here, count how many total place values you have. So 3, so starting at your last digit, work your way forward, 1, 2, 3. So 0.735, 735 thousandths. And then don't forget, negative times a positive is a negative. So, and again, I just throw that in my calculator and get an answer. But that's how you do it. When we talk about scientific notation, we might come back to this idea and say, why is this, why are there 3 place values if there's 1 place value here and 2 place values there? And it has to do with powers of 10 is what's going on there. Dividing decimals. So let's say I have 0.035, and I'm dividing that by, say 351. 0.24. Okay. Well, notice I wrote this as a fraction. I did that on purpose because I know with equivalent fractions as long as I multiply top and bottom by the same thing, then it's still an equal value fraction. So I'm going to multiply this bottom by 100, and what that does is every time you multiply by a power of 10, it moves the decimal 1 spot over. So multiply by 10 moves 1 spot, multiply by 100 moves 2 spots, multiply by 1,000 moves 3 times. So this bottom becomes 24. I'm also going to multiply the top by the same thing, by 100. So this is going to move 2 spots, and this is going to become 3.51. In order to divide decimals, your divisor needs to be an integer. So if it's not, you need to move the decimal the same number of places on the top and bottom to make the bottom an integer. The top does not need to be an integer, but the bottom does. And then you're just going to divide that. And I'm going to do long division here. So 24 does not go into 3. 24 goes into 35 one time. That gives me 11. Bring down the next one. 24 is about 25, so about 4 quarters. So we'll say 4, 16, 8, 9. 5 will get us to 101, so 15. And then you can add another 0 here. Again, this is like 25, so that'd be about 6, 4, 24, 14. That's 6, 0. Bring down another 0. 24 goes into 60. Well, 12 goes into 65 times, so 24 would go in there twice. That'd be, I need to move this down a little. Let's see if it'll, I think it'll do it on its own. All right, 20, that's 12. And notice this is half of what I'm dividing by. Anytime that's the case, the next digit is a 5. You can think of a half as the same as 0.5. So here's my answer to that division. And again, I would just throw that in calculator if I was using a calculator, but we're kind of going on. All right, let me stop here and we'll start another one to talk about some more review.